Hello everyone and welcome back to the math. So in this video, we are going to talk about number of roots in a quadratic equation. If you haven't watched the previous videos regarding quadratics, I'll leave a link to the playlist in the top right of this video. So, like I explained before, we will learn how to determine whether a quadratic equation will have identical real roots, no real roots, or distinct real roots without calculating for the roots. And the problem in this section will be quite tricky, but I think with enough exercise, we'll be used to it. So we are going to do some examples directly. So the first one, x squared minus 2x minus 3 equals to 0. So first, let's try to find the roots. We know that we can try to factorize this, or we can try to use the quadratic formula, and we get that x equals to -1 or x equals to 3. And in this case, we know we have two distinct real roots. Distinct means different. Let's try to go to the next example, which is this. X squared minus 4x plus 4 equals to 0. So again, we can try to use the quadratic formula, and we get that the root is going to be x equals to 2. And there's only going to be one answer. And in this case, we say that the quadratic equation will have two identical real roots. So technically, there should be two roots. It's just that we have identical values. So we say we have two identical real roots. Last example, it's going to be this. If we try to use the quadratic formula, we know that the x value is going to be an imaginary number. And in this case, we say that the quadratic equation will have no real roots. But again, how can we know whether it has one real root, two real root, or no real root at all without calculating for the actual roots? The clue lies in the number inside the square root, as we will see next. Let's try to review again on the quadratic equation. So we know that this is the quadratic equation, and we need to focus our attention on the expression inside the square root. Inside the square root, we have b squared minus 4ac, and b squared minus 4ac is going to be called a discriminant. And usually we write it as d equals to b squared minus 4ac. If we try to take a look at the examples worked before, for the first one, we know that we have two roots. And if we try to check the discriminant by inputting the ABC values, we know that the d is going to be 16. Now, we can actually make a conclusion that if the discriminant is positive, we will have distinct real roots. In the next example, we know that we have one x value only, or you can say that we have two identical real roots. If we try to check the discriminant, we basically get a 0. So the next conclusion, if discriminant is 0, we have identical real roots. And in the last example, we know that we have an imaginary number as the root. And if we try to check the discriminant, we get a negative value. So if the discriminant is negative, we have no real roots. Now let's try to see how we can visualize this in a Cartesian coordinate geometry graph. So if a quadratic functions have two distinct real roots, we can try to say that we have two x values when the y is equal to 0. And we can also remember that this actually means the x-intercept. So if we try to make the graph, it's going to look like this. And we know that the parabolic curve will intersect the x-axis twice. This is called the x-intercept, and we have already learned this when we are sketching the quadratic function before. And again, it cuts the x-axis twice. For the next example, we know that we only have one x value when y is equal to 0. So you can imagine that the parabolic curve will only touch the x-axis. So you can say that this is tangent to the parabolic curve. The x-axis is tangent to the parabolic curve. And in the last example, we have no real roots, so we should not have any x-intercept, so no x value when y is equal to 0. And you can see that the parabolic curve is actually separated from the x-axis. So it doesn't touch the x-axis or even intersect the x-axis. Right, let's try to get on with the examples. So we need to determine whether the following equations will have distinct real roots, identical real roots, or no real roots. Again, we just have to check for the discriminant. So we can try to find the ABC values and then input it in the discriminant formula. We get that in this case, the discriminant will be positive. And since we know that the discriminant will be positive, it will have distinct real roots. In the next example, if we try to find the discriminant of this quadratic equation by inputting the ABC values, we know that we will have a negative number, so it will have no real roots. And in the next example, if we try this quadratic equation, we try to calculate the discriminant inputting the ABC values, we got that d is equal to 0. If d is equal to 0, that means we have two identical real roots. Now, this is one of the more tricky examples shown usually in this material. So we need to find the values of k in which the following equations have identical real roots. I'll try to put the formula for the discriminant in the top right in case you forget. And we have to remember that if a quadratic equations have identical real roots, the discriminant is going to be 0. So after this, we can try to input the ABC values. So k squared minus 4 times 1 times 2 equals to 0. And we have the following equation, k squared equals to 8. And then we can try to find the k value, which is plus or minus 2 times square root of 2. In the next example, it's going to be a bit more complicated, but the method is going to be the same. Again, we know that to have an identical real roots, we need to have discriminant equals to 0. So we can try to input the ABC values just like what we did before. And we can try to simplify the equations. So it's going to look like this. And in the end, we know that k is negative 3. In the next example, it's going to be very similar to the second one. It's just that we have a lot more k to determine. But again, the method will be the same. So d is equal to 0. You can try to input the ABC values. And you end up with another quadratic equation, but that's okay. This quadratic equation is used to find the k value. So we know that we can try to factorize this, and we got that k equals to 0 or k equals to negative 8 over 9. Right, now let's try to get on to this example. We need to find the values of k for which the following equations have two distinct real roots. But as you can see, the right side of the equation is not equal to 0. So we need to adjust these equations first. We need to make it such that the right side is equal to 0. So we can try to move the k to the left side. And again, we need to remember that the right side should always be equal to 0 in this case. After this, we have to remember to have two distinct real roots, the discriminant needs to be a positive value. So again, we can try to input the ABC values. And remember that the c value in this case is 5 minus k. Not only 5, not only k, but 5 minus k. So the a is 1, b is 4, c is 5 minus k. After this, you can try to simplify the inequality, and we get that k should be greater than 1. In the next example, if we try this quadratic equation, it looks complicated, but again, we have to make the right side equals to 0. So we will move everything on the right side to the left side, becoming like this. And then we can try the similar method. So discriminant is positive. We can try to input the ABC values as usual. And then we can try to simplify the inequality so that we have k squared minus 6k plus 8. And again, we can try to solve this with the method we learned previously. So we know that the range of k that satisfies this inequality is going to be k less than 2 or k greater than 4. Now, this one is going to be very similar to the one previously. We need to find the k value such that the equations have no real roots. So first step, we need to make the right side equals to 0. And then we have to remember that the discriminant should be a negative number. And again, we can try to input the a, the b, and the c, and eventually we get a simple linear inequality. So k should be less than negative 2. In the next example, it's going to be a bit complicated, but again, we will use the same method. So we can try d less than 0 directly, since the right side is already equal to 0. We can try to input the ABC values, simplify the inequality, and we can try to factorize this. And then we can try to use a method we learned previously. So we know that the range of k that satisfies this is going to be negative 10 less than k less than 2. So k will be between negative 10 and 2. Right, so usually in this topic, it's very rare that any teacher will issue a word problems, but I will try to give you as an example so that you can try to relate this to a real life problems. So A marketing manager is evaluating the performance of a monthly advertising campaigns for a year. Based on the data, the company's monthly profit in thousands of dollars can be modeled as the following quadratic function, where X is the number of advertising campaign in that month. The management wishes to know whether it is possible to generate a monthly profit of $50,000. Right, so let's try to gather up all the known information. The first one, we know that this is the profit equation. The second one, the targeted profit is actually 50. Now, the management wishes to know whether we can have an X value such that P of X can be equal to 50. So we can try to do the math. We can try to input P of X equals to 50. And then we can try to simplify this so that we get a nice quadratic equation. And remember, we need to know whether such X value exists, so we can try to use the discriminant. We can try to check the discriminant of this equation. So if we try to input the ABC formula, we get that the discriminant is negative. So what does this tell us? This tells us that there is no X value such that we can generate a monthly profit of $50,000. So that's how we use the discriminant in a word problems. Right, next example. So a ball is thrown upward from ground level. Its height in meter after t seconds can be estimated as the following quadratic function. A window is located 10 meters above the ground, so will the ball pass the window once, twice, or never? So I will try to illustrate this problem. So it's going to be like this. Let's say we try to throw a basketball and then we throw it so high and we want to know whether it will pass the window twice. So that means once going up and then going down, or it's just going to be once. That means it will only reach the bottom of the window, or never, meaning that you throw it too low. Okay, so let's try to gather up all the informations. So we know that the motion equation is going to be this, and we know that the expected height should be h of t equals to 10. And again, we want to know whether such t value actually exists. We can try to substitute ht equals to 10, and then we get ourselves a nice quadratic equation. After this, we should try to check the discriminant. And if we try to check the discriminant, we know that d is actually 420, which means d is a positive number. So there will be two distinct t values. And we know the conclusion, the ball will pass the window twice, because there are two t values when the height of the ball is 10 meters. Right, so these are the exercise that I've prepared for you guys. I hope you can try to do these exercise so that you can be more familiar with the discriminant. Right, so that's it for this video. In this video, we learned about the number of roots in a quadratic equation and also about the discriminant. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.